Okay, Assalamualaikum warahmatullahi wabarakatuh. So today be looking at the peak inverse voltage of a half-wave rectifier. So if I draw the circuit, it will look like this. A half-wave rectifier, you have the transformer, right? Primary and secondary. Then you have a diode. Then you have a resistor, and the voltage across the resistor is the output. Okay, the output voltage is the R, and then this is the diode. Okay, so when we talk about peak inverse voltage, we are talking at the we are looking at the reverse bias, because peak inverse, I stands for inverse, so it must be at the reverse bias. So you have you have an input like this, will be at the negative cycle of the the input. Okay, so negative cycle of the input, then this VP, VS, then it will be plus here, minus here, because you're looking at a negative cycle, right? If this happens, then you know the diode will be in reverse bias. Hence, here the what do you call it? So therefore the diode should be in reverse bias. So the voltage, the polarity of the peak inverse voltage, the diode in reverse, so this will be negative, this will be positive, right? Because the diode in reverse bias. So if that's the case, if I just redraw this, if you want to do a KVL, right? Let me redraw this so it becomes like that. So it's like you have a battery here. It's like as if you have a battery, negative and positive. You have negative here, positive here of the VS peak, and then you have tried to find the peak inverse voltage, and then there's your resistor there. Okay, so the peak inverse voltage over here, and the polarity will be minus plus here. Okay, so if we do a KVL over here, what you will get is plus VS peak, then minus PIV, and then R. So since this is reverse bias, there's no current, I equals to 0, right? So then equals to 0, right? There's no current, so IR will be 0. So therefore your peak inverse voltage will goes to VS peak. So that's how you get the value. Okay, so that's for the for half wave. For a Centre Tap transformer, okay, so let's look at the Centre Tap transformer. The circuit for a Centre Tap transformer looks like this. Rectifier. Okay, so let me draw this. So you have a transformer, but it's a special transformer where you have the Centre Tap, and you have a diode over there. Also you have a diode over here. Then it's being this is connected together, and this connected to the resistor, and the output is taken across the resistor. Okay, basically this is the circuit. So you have two diodes, T2 and T1, and as you know, Centre Tap transformer is a special transformer. So as if you have two polarity over here, you have two VS. Yes, yeah. Okay, so this is your primary. So again, we are looking at the peak inverse voltage. It means that we're looking at the negative cycle over here, which means but since it's a full wave rectifier, Centre Tap is a full wave, doesn't matter if you look apa nama. So maybe let's look at the when it's a positive cycle over here. Positive cycle means that here, it means that, let's say this will be positive here, this is negative here, positive here, negative here. Let's look back at this. So let's look at the positive cycle. So VS plus minus like this. So what happens is you will see that the diode 1 will be on and diode 2 will be off. Okay, but we are interested in the peak inverse voltage. It means that we're interested when the diode is off. So then we are trying to find the peak inverse voltage at the diode over here. Okay, so that's the case. So if I were to draw this circuit again, just to get the KVL at the positive cycle, so you will see it's like you have a 2 battery over here. Okay, 2 VS peak, and then VS peak over here, and then you have the diode, okay, which is on D1. Then you have the, so we are doing a loop like here, so there's no resistor, and then you have the peak inverse voltage. So D2 is reverse bias. I mean, it will be minus here, positive here, right? So it will be it will be minus here, positive here, PIV. Okay, if that's the case, because the diode is in reverse bias, so negative is applied to the P and then positive is equal to the N. So that's why the polarity like that. Then let's look at the KVL. If I do a KVL over here, what happens is, so this is apa nama ni, plus minus, so it will be VS peak minus VS peak, and then minus VS peak. Then don't forget you have plus minus V gamma over here, then plus V gamma, and then plus PIV equals to 0. Okay, so if you rearrange that, you get the PIV equals to equals to 2 VS peak minus V gamma. So that's the value for the peak inverse voltage for a Centre Tap transformer. It's much simpler if you understand. Okay, good. Now let's look at the final one, the peak inverse voltage for the bridge.